Hi, welcome to Out of the Blue. I'm Blue, and this week we're talking about a really exciting topic, and that is dark energy. So if you're ready, I'm ready. Let's get started. To start off, I want you to imagine our universe with me. So when you imagine the universe, try not to think of what's in the universe, and just try to think of like a fabric sort of thing, sort of like a balloon. And I'm actually going to be using a balloon a lot in this talk. So before the Big Bang happened, or when the Big Bang happened, everything was all in a single point. So everything was touching. I have a balloon. There are 2 points on it that I've drawn on in shiny Sharpie, and those points are touching, basically, because there are no dimensions to this balloon right now. Well, when the Big Bang happened, the balloon essentially blew up to massive proportions and gave us everything in the universe, right? And it kind of continued getting bigger from there. Well, scientists wanted to know how quickly it got bigger, if it kept getting bigger, if it started collapsing because of gravity, or if it stayed one size. And what they found actually kind of surprised them. So here's our universe after the Big Bang, or basically what we're living in now. As you can see, the 2 dots on the side are way farther, especially because in the universe we can only travel on the surface of this balloon. That's kind of why there's no center. Because there's no center of the surface. It's in the middle, which is in another dimension, and we can't really make sense of that. So, scientists wanted to see what was happening to the distance between the dots. It should stay steady if our universe is staying steady, just like this, right? And if our universe is going in on itself because of gravity, then the dots should get closer and closer together. Well, what they found when they were looking at the dots is that not only are they getting farther apart, so like the balloon's getting bigger, but they are getting farther apart at an accelerated rate. They're not just growing apart steadily, they're like growing apart and getting faster and faster and faster away from each other. And they didn't know what caused that. They had no clue what was doing that. It didn't match any of the models that they had. So what did they call the mysterious force that was separating everything in the universe? They called that dark energy. Here's our universe, and it's expanding, and we have no idea why, but we call it dark energy. So that's basically what scientists know about dark energy, is that the universe is expanding and we don't know what causes it. Based on all the calculations we've done, we've figured out that dark energy actually makes up 70-something% of our universe. How did we get that number? Well, if our entire universe was made of matter that we know about, it would collapse inward. If it was all made of matter that we know about plus dark matter, it would do the same thing. There's enough dark energy that it cancels out dark matter and regular matter by such a degree that it is literally 70-something% of our universe, which is a lot. Not to mention dark matter is like 28% of our universe, so we only really know about 2% of our universe, and that's the matter that we know about, and as you know, we don't know everything about that either. So there's a lot of unknowns in science, and here's where people like you and people like me come in. We're still learning a ton about our universe. I'm trying to get involved with the HETDEX project. That's the Hobby Everly Telescope Dark Energy Experiment. And what that's doing is it's kind of trying to measure the expansion of the universe in earlier epochs, so like when the universe was only 10 billion years old instead of 13 billion years old, just to see how that compares to what it's doing now. And the way we do that is actually using spectrographs, and I'm trying to work on building the virus spectrograph to go on the Hobby Everly telescope. And stuff like that is super easy to get involved with. I went to someone's office and said, hey, what can I do to help? And she said I could help with actually building the spectrographs or with modeling and simulations, which is super cool because we're on the brink of discovering great things about our universe, and it's that easy to go out and do stuff. So I definitely encourage you to do it, to tell your peers about it. Maybe share this video and tell them that we need to figure this stuff out. So get to it, and I'll see you next week.